Welcome back to another Terran R monthly update. Let's dive in and see what's new across design, build, test, and launch. As the program matures, we're releasing parts in large groups through our design sprints. In November, we released 1,602 parts, unlocking manufacturing and bringing us closer to first flight. We're also designing for Terran R's long-term future, having completed the Block 2 vehicle conceptual design review this month. Our block upgrade strategy outlines a path for performance, manufacturing, and reuse upgrades to increase flight cadence and reduce cost. In November, the team completed all circumferential friction stir welds for the Stage 1 tank for Flight 1. Measuring in at 163 feet long, the tank consists of 8 barrel sections and 3 domes, joined by 10 circumferential welds. The tank will now head to integration. With the first and second stage tanks complete, focus shifted towards the inner stage. Vertical friction stir welding of both the forward and aft barrels for the inner stage is complete, including stringer welding. Now, they will progress to paint and mechanical assembly. Progress on the thrust structure integration continues, with heat shield system installation underway. In propulsion, the team manufactured, assembled, and shipped 2 more engines, one second stage Aeon-V development engine and one first stage Aeon R flight engine. The team is also building out factory infrastructure to support high-rate manufacturing. Recent wins include bringing online more new CNC machines and powder bed fusion printers in the expanded machine shop, installing a thrust structure breakover tool, and proof testing the composite overwrap pressure vessel install tool. Following hardware integration of the thrust structure hardware in the loop test infrastructure, the HITL table has been handed over for software integration ahead of run for record tests, and avionics work on the Stage 2 HITL build has begun. This month, the team lifted the Stage 2 tank onto the structural test stand in Long Beach and successfully completed acceptance testing. The multi-week test campaign applied over 30 load cases, including pressure proofing and testing ground and flight loads to verify workmanship of the tank structure and demonstrate positive strength and buckling margin to flight loads. The tank will now be handed off to manufacturing for integration. We also completed transonic and supersonic wind tunnel testing for Terran R's first stage entry configuration, running over 100 tests on the full Stage 1 body model with movable grid fins. On the propulsion side of the house, we completed the first Aeon-V second stage engine development test campaign, collecting key data on startup conditions, suction margin, and the stub skirt. Acceptance testing of first stage ANR engines continues, with a second flight engine completing testing and another flight engine arriving on site and being prepared for test. At the component level, the team ran stage press valve hot gas testing, aimed at targeting the stressing thermal transients this valve will need to operate on the stage. Infrastructure build-out continues at NASA Stennis with foundation work for a new hangar in progress, which will expand office, manufacturing, and stage storage space. Nearby, work on ground support equipment hardware to support the A2 stage test stand continues, with helium recovery storage tanks being installed. In Cape Canaveral, renovation of LC-16 continues across all corners of the site. The water tower tank is now set atop the downcomer and foundation legs, with final weldments continuing. At the horizontal integration facility, siding now covers over half the building. Exterior ladders, walkways, and stairs are in place, and the future overhead cranes have come off the production floor. Cement work is progressing above grade on the launch mounts retaining walls, and structures and foundations for both lightning protection system towers are complete. At the LOX farm, we received and installed 3 170,000-gallon tanks. LC-16's high-power electrical distribution system officially transitioned from Terran 1 to Terran R architecture. Alongside continued technical execution, we also announced a multi-launch agreement with global satellite operator SES, with the additional Terran R launches for SES's GEO or MEO satellites will help expand access to orbit and power global connectivity.